Hey everyone, Meteorologist Tuttle with you. We're gonna do a live update, couple fold, two reasons. One, I hate Facebook. Let's get that out of the way. It has been giving me fits the last 24 hours. It wouldn't connect earlier, so that's why that didn't work. I'm hoping it's working now. Oh, where'd my little thing go? Get back up there. There it is. So what we're going to do is talk about, there was a storm north of Tulsa that finally got its act together, so I'm going to cover that on radar here in a minute, and then give you the forecast, what we've seen so far for today, kind of look a bit deeper into what's going to happen on Saturday, and I'll do another live tonight, around 9:30, just see what the new data shows, but at least that way you're up to date in case you can't make the one that coming in for tonight. So thanks for joining me. If you do look from Oklahoma City, we can see those storms out there across far eastern and northeastern Oklahoma, just even from my vantage point. When we look at the storms in Tulsa, they were, at one point when they first started, looked pretty good. In other words, like they were going to try to produce a tornado when it was west of Tulsa. But it fell apart rather quickly and it never got its act together. In the last 10 minutes, though, it did have a little bit of a hook echo on it, and it still does around the Chelsea area. This just happened just a few minutes ago, so the Weather Service did issue a tornado warning for the particular storm. Now, it does not appear that a official tornado has touched down, but what it does indicate is that it could, at least for the short-term period, the probability of a tornado is right around 50% in the algorithms, and this will work its way through the town on the north side of Chelsea, so make sure you're in your shelters, which basically means the lowest floor away from all outside walls and windows. It should be coming through on the northwest side of town. This little marker right here indicates that. But like I said, as far as the velocity structure to this, there's not much to it. Like I said, it for about a minute or two, they looked pretty good, and then it quickly kind of became a little less organized. But that sometimes happens. Not all tornadoes either A, develop well and or last that long, much less. So right now, that's kind of the latest going on in that particular part of the state. There's no other tornado warnings anywhere else, so it's just this one. We'll look at the wording on this. Let's see, movement is to the northeast at about 38 miles per hour. So hail's up to about 1.25 inches in diameter. So we see little purple areas here on the map, indicates a large hail from the radar reflectivity. And the towns, of course, we've got Chelsea right now, and then we have Bonita and Afton coming up around 628. So there's no other interactions with storms. There was a little bitty shower that kind of merged with this one, and I think that kind of helped nudge it to produce a tornado briefly, or at least try to. But that sense has been absorbed, and it's going to be on its own again. It needs to kind of move more to the east to kind of take advantage of the relative inflow of the storm environment. So we'll see what it can do. But for right now, stay in your shelters for the next at least 10 minutes here in the Chelsea area until that storm moves by you. And then in Bonita, just a heads up that if it still holds together, it'll be making its way toward your area. And I'll check back on this one here in a minute. But I want to kind of give you that update as to what's happening. Let's see. Let's go. Which one I want to do first? We'll do this one. So this is the satellite viewpoint from this afternoon, and we had the dry line that we talked about fire off just a few storms. Here in east central Oklahoma, they didn't do much. They went up. They looked hard there for a minute. You can see little blow-ups here of the white on the screen. And then they started to basically diminish. The only ones that really kind of kept going were the ones that fired up farther into northeastern Oklahoma near the Tulsa area and into Kansas. So there has been a tornadic thunderstorm in Kansas that's dropped several tornadoes in southeastern Kansas. So that one's been pretty active. It was a little bit more favorable environment than the rest. So that's what's been going on here, at least short term. Let me see, let me mute that. All right, a few other things we want to talk about. Right now, the Storm Prediction Center doesn't have any discussions for Oklahoma. So in other words, the little red outlines is for Texas for more thunderstorms in that area and up around the Nebraska-Iowa border at this point in time. For Saturday, we're looking at, this is from the Storm Prediction Center, their latest outlook from today, which indicates the moderate risk here in orange, which is right here over central Oklahoma and up across Nebraska and Kansas and parts of Missouri and Iowa. The little right panel is where you have the tornado probability ring shaded here for a higher confidence of tornadoes within that zone. Doesn't mean you can't get them outside of the avocado, so to speak, but that's just where the most concentrated parameters are located. The western panel here is for the hail, so a large area to experience some hail and a large area to experience some wind. And what is not on here is significant flash flooding. That's going to be another problem we'll have to deal with. So here's a kind of close-up view. Let me go to Saturday. So here in Oklahoma City, points out to the west. We're all covered underneath the moderate, or excuse me, the enhanced area for severe weather. Will they upgrade to moderate? We'll see. The Storm Prediction Center is kind of just discussing that right now, and maybe in their later outlook they might do it. But Norman has a medium tornado potential up to baseball size hail, 60 to 80 mile per hour winds. As I said, for the tornado risk, they kind of have a medium across most of the area. It does say strong tornadoes are possible in the afternoon and evening. And we're going to look at this. There's going to be a couple of waves coming in for Saturday. It's going to mess up some of your plans. We're going to kind of time that for you. Heavy rainfall, by the way. Flash flood risk is moderate from Oklahoma City to the south and east. The newest data is really trying to put a hard line in the sand on where the flash flooding will basically be a problem. It's right about literally where this red line is. So Weather Service did a good job at highlighting probably where the most rainfall will occur with this particular storm system. On Sunday, the storm should be in the far eastern Oklahoma and not nearly as much ingredients to work with as before. So it should be at least on a little lower ability to produce, as much severe weather as we'll have, say, for example, on Saturday. And as we're talking about here for today, this was the AI models indicating where the higher potential for tornadoes were for today. East of us, it didn't do too well, just to let you know. I show you this only because these are cool tools, but they're not the best, right? They still have their flaws. But I still show them because it's a learning experience for both me and you in case you see this stuff out there and I see it, as to how much you can trust it and say, oh yeah, that's really going to nail the forecast. Well, so far I haven't been doing too good, at least in our area. Let's see. Let's go for tomorrow. One of the AI models did favor the area here of central and northeastern Oklahoma, and we'll get new data tonight, and we'll update those and see. The analogs for the event tomorrow kind of favor for tornadoes here in this area, oddly enough, but we're going to shift it just a little bit more to the east and maybe cut some of this other part off out here in the Panhandle because the dry line will be east of that area. But again, this is just a comparison of past events. It's not an actual forecast, so it just kind of shows you what is potentially there in the data. We look at the CWASP numbers. Basically, any number that's up over a 75 or 65 rather has the potential of the environment to produce a stronger tornado. I mean, in other words, an EF2 or EF5. So as we head into tomorrow, you can see that pretty much anchors right here over central Oklahoma. So that is why we do have the potential for some strong tornadoes for tomorrow. Let's see. Let's take a look here and get into some of the data. I do want to show you the upper levels of the atmosphere. It's the jet stream pattern where we track our next storm system. Here's the first one here leaving us. Here comes the next one coming in. It's got a lot of energy and lift associated with it on the bottom end of the trough that's going to swing through. So I put this in motion for you. You can see how it spirals through into Colorado by tomorrow afternoon. And out ahead of it, it does have quite a bit of lift that's going to be kicking through a little bit later. In other words, this is going to be kind of in an evening to overnight period. Once again, we'll have a little wave kickoff earlier on. Let me back this up a little bit. See those little speckles you see on the map? So there is a little wave that does kick off here, and I'll show you what that looks like close-up view in a minute. So that's round number one, and then we'll get round number two as the next wave kicks in for overnight. And see what it does here. Just blows things up here over central Oklahoma. So basically one wave and two waves, and we're going to see how that translates into the risk for tornadoes. We do look at the mid-levels of the atmosphere for the omega, the lift, to try to get things going. Where you do see the reds, that indicates you do have lift overall in the atmosphere. So we head into Saturday morning. You see a big chunk of it starts right here, and this will shift into western and central Oklahoma during the morning hours into our lunchtime hour. Then we'll watch that kind of move off, and then we'll have another round that just starts to explode in that same track, that same area. And even out here in the eastern panhandle along the dry line as we head into the afternoon and evening. But if you notice, it really gets really strong right here. That's a really bad convective feedback signal, which means it's producing a ton of precipitation for a good 6-hour window. Again, that's bad news when it comes to flooding. You can see it didn't move a whole lot. It's very slow. Kind of started here, then went here, and then went here over a 6-hour to 8-hour period. All right, so anyway, that will move off for Sunday, and then afternoon, again, it kind of anchors now across this part of the state versus the rest. Now, part of this is going to be why we're getting some storms overnight so much is because of the jet stream. So this is at 300 millibars. Let me show you what happens to the jet as you look to the southwest of it. See how it kind of sneaks in here? for Saturday. Now, the early part of the day, we're in the wrong position of the jet. In other words, if you want a really good part of the lift of the jet, you split the jet axis like so, all right, and you crisscross it. So this is a favorite area for lift, and this bottom end is a favorite area for lift. This one, not so much, and this one, not so much. Now, you can get storms in these areas, but they favor the other just due to the way the process of the atmosphere goes. But let's just put this into motion for the afternoon. So what this causes is a lot of lift in this area, all right? Kind of neutral, as we said, for that first wave. But the tail end of this, watch this tail end of this moves into central Oklahoma as they go from the late afternoon into the evening. So we'll go to midnight hour. So again, midnight hour, our jet is now crisscrossed like so. And so we're now on the right entrance region of the jet, which means we have a lot of lift to continue to produce those storms overnight. Think of it like a giant vacuum cleaner, just sucks that air straight up and allows those storms to continue. So that's one of the main factors why we're going to have some overnight storms just that doesn't want to stop, because we have favorable lift in the atmosphere to continue for it to go, both in the storm system track and its mid-level lift as well as its upper-level lift. At the 500 millibar level, let's see, we do have a nice jet streak that comes in right over Oklahoma. These are up 83 knots. That's a lot of wind out there. That's enough to keep it going as far as storms are concerned. Let's go into 850, I believe I got loaded up. So yeah, 850 on Saturday. We do have a little bit of a south to southeast wind here midday, and I'm going to show you why that is here in a minute, because it affects how our forecast is going to go. But for the evening period, it does go more of a southerly direction, but very strong. So we also have strong winds over 50 knots, which is good for storms and for them, for their life cycle and their life. And then it really cranks up even higher than that as they get going in a squall line fashion. So there's going to be a lot of wind shear to feed this system overnight on Saturday. And each time we've had these overnight, the first event, very capped atmosphere that almost completely eroded. Last night, we had a half and half. A cap initially, and then it eroded enough to keep some of those storms going and get a tornado or two out of it, along with some pockets of wind damage. Saturday night, again, we're in a situation where it looks like we're going to erode the cap completely if you believe the model data. Let's see. For right now, let's see. The dry line will retreat back out to the west. Let me park this thing here for Saturday. So for Saturday afternoon, the dry line stays anchored right along the Texas border. So this is going to be interesting because we're going to have two areas where storms will try to develop Saturday afternoon. So we're going to have this area along the dry line where the cap breaks, because believe it or not, a cap will form in this area. Where you see this little purple area, this is kind of a theta E axis for moisture in a relatively uncapped atmosphere by about this time forward. And it's a lot of moisture. Dew point values in the low 70s and upper 60s coming in. Again, that's very favorable for tornado genesis. One of the key ingredients is to have that good low level moisture. And we also need instability, of course, with that, and that's going to be around too. So here's midday Saturday, where we have CAPE values well in excess of 3, even 4,000 joules per kilogram. And you also have some decent wind shear as well. So if you take a look at a forecast sounding here for Oklahoma City area, what you'll notice on Saturday afternoon, this guy right here. So there is a cap in place for Saturday afternoon. So I'm going to show you how this looks when you break down the timing of the rain and what you can expect out of it and during that time frame. As we go into the evening, so let's go to 6 o'clock, 7 o'clock. So we still have widespread instability across the region. Let's go overnight to midnight. We still have it. Now they'll start to erase here because the storms have formed. It's going to erode the model's data output, but it's still there. You just have to visualize it. So in other words, we have overnight shear and overnight instability, so that's not going anywhere. Okay, so let's talk about the significant tornado parameter. So for Saturday, it does expand. Let me go back to the morning period. So there's the morning. So most of it kind of anchored out in this area of the state. Again, the numbers, the higher the number basically just means the more volatile the ingredients. As we head into the midday hour, you see how that kind of expands just because we're getting better ingredients here in the atmosphere to work with. As we go into the evening hours, you can see how those numbers go higher. The colors get a little brighter over that area of in question that we're talking about. Through the evening. I mean, off the charts here in the Panhandle, for example. And when you see these, a lot of times storm chasers will pick them and they'll plot them and they'll have some really crazy numbers on them. They'll get really excited because they pick the very best spots. But You'll also have, in this case, a cap, in this particular case along the dry line out here in western Oklahoma, even in the area that's most favorable for maybe stronger tornadoes. Now, regardless, by midnight, we still have that whole thing over us. So any storm in this environment that is rooted in the boundary layer can and will produce a tornado, given other conditions around that particular storm environment. All right, so let's move into the next piece of equation here. I think this really is what is telling the tale in the timing and the situation. Okay, so this is, in the past we talked about the cap. So the cap is a layer of air. It's warm air at, varies, but from 4 to 7,000 feet roughly. Now, air can't rise through it. It's like, think of it like a balloon. It can't go through the air. Now, eventually, if the cap is weak, you know, you can get a few balloon parcels that'll go through. It'll rise and get you a thunderstorm. But if it's too strong, nothing happens. Well, along the leading edge of this capping layer, which is warm air, you can get the parcels to rise through it, right? So you can get some thunderstorms, meaning the cap over here is very, very weak or non-existent. Whereas in this layer, this is where it starts, and then it's very strong, and maybe it gets stronger as you go in, you know, say westward. All right, so let's take a look here at the map. So we can look at that in the form of temperatures, okay? So let me start from ground zero. So ground zero today, we had a temperature of 17 degrees Celsius at this level of the atmosphere. So I'm going to show you what happens. So as we go through time, for this afternoon, we warmed up to 19 degrees. So in other words, our cap build, in other words, it got warmer. All right, now we're going to go into the midnight hour for tonight. The cap starts to build overnight. Now we're at 19 degrees. All right, so let's just zip on into Saturday. So here's Saturday morning. All right, so we're starting off the day at 21 degrees. In other words, our cap has built in overnight tonight, which is normal, into tomorrow morning. So what happens? Well, look out here to our south and west. And this is important. You see this little wind shift right here? You have these wind barbs out of the west-northwest, and then you have wind barbs here out of the south. So basically what you have is one of those little mid-level kickers, all right? It's a little axis, a little shortwave axis that gets picked up here at this level, and it swings through, and that is what is going to trigger the showers and storms in this area. And then those will be the ones that move into to southwest and central Oklahoma. And what you see here is temperatures getting cooler, 17 degrees, 17, 17. Up here is 20, 21. So that is kind of where you have a little weaker cap as a result of that extra lift. So let's go into the next frame for 13, 14, 15 Zulu. So now we're in the morning hours. So what you've noticed here in central Oklahoma, our temperature is still about 18 degrees. We cooled just about a degree or two, but not much. Where this little wave had kicked through, it did cool things down a little bit more. Of course, we've got the storms, but those storms, I still believe, are going to be a little bit on the elevated side when they start. So let's go to midday. All right, so there's now the afternoon. We're still about 17 degrees, so we're still probably holding at a weak cap. Let's see what happens as we go into the afternoon. So at 0Z, so about 6, 7 o'clock. So the cap is kind of rebuilt in this area here in western southwestern Oklahoma, right around 20, 21 degrees. Now here in northwest Oklahoma, 17, 18. So the models will probably try to produce a few storms out here in the far northwest Oklahoma along the dry line. So it's going to try to break the cap because it looks like it's a little weaker here. Now for us, we don't have anything to kick off those storms. In other words, there's nothing here to get things going yet. So let's go into the evening hours and look what happens. So I'm going to go back to here. I want you to see what happens. So we get focus on this little area of brown as it kind of shoots eastward during the afternoon and evening. And it gets to right about here, okay? So we go forward, stops right about there. This is around 9, 10 o'clock. Now, what happens is that capping elevation kind of shifted across all of western Oklahoma, capping the environment to prevent storms. But what it didn't do is it didn't cool us down. Matter of fact, we got cooler just by a little bit. So the atmosphere, due to mixing, we end up actually cooling down to a period to where we basically become uncapped in our atmosphere. And so now that allows us to try to bust through that layer because we don't really have a good strong capping layer over us anymore. And this is the timing as to why this comes in and starts to develop storms late during the evening. We have just a little bit of convergence, these little light southwesterly winds coming into a southerly wind area where we have an area to kick off some storms. This is the exact same thing that happened down here in Texas Saturday morning to get those storms going. So now we're repeating the process, but we're repeating it even up here in the central Oklahoma. And so that's why they don't develop on the dry line and they actually develop right on top of us. And we'll see that here in the data. We'll go through time here. So let's see. Here's the morning stuff. All right, moving through. Kind of falls apart, which tells me that more first morning showers does probably stay mostly elevated. Now there may be some spots that kind of struggle with that and might actually get down the boundary layer, and there are some helicity tracks in here. So it's possible you could get a brief tornado out of that, or at least some hail and wind, but otherwise the signal's pretty weak for those particular storms. And as we go into the afternoon, here's where the cap is a little weaker up here in northwest Oklahoma. It's trying to produce a couple of storms on the dry line, as it should, around 4 and 5 o'clock. And those try to get going, but they kind of fall apart. Again, because up here, atmospheres are a little warmer. Remember, there was like a little sweet spot right here in the temperature data, and then it's warm out ahead of it, so they don't do too well. They head into a stronger cap and they die out. Then we get into this. Remember this area of the atmosphere where we're talking about, where the cap was supposed to completely erode by sunset and then kind of stay that way. So we go into the 7 and 8 o'clock hour, you can start to see just a bubbling of storms glowing up from just west of Tulsa, right around basically Stillwater, Ponca City, up into Kansas, back through the Oklahoma City Metro, on the way down south and southwest into Texas. And so that is the axis now of storm development in this region. So again, the dry line's still way out here, but it's not going to do anything because this whole area is capped. So instead, we fire storms off where we're on the edge of the cap. So in other words, we don't have that lid in the atmosphere to prevent storms from forming. We have a theta E axis just for moisture coming in. So therefore, we just get a blow up of storms that are just one big cluster. It looks like a big line. Ironically, you can't really have a stationary squall line, even though that kind of looks what it looks like. A squall line is usually always on the move, and it will eventually move, but the initial point of this is going to be a cluster of just a lot of cells just merging all over the place in a linear fashion. And within this line, you will have pockets of hail, pockets of wind, and yes, a few probably strong tornadoes. And it's not going to move too fast. So we're talking about a lot of rainfall. So as we go into the midnight hour onward, you can see how that progresses to the east very slowly into Sunday morning. Just rain, rain, and rain. So this is really probably going to be a mixture of severe weather, but a very heavy leaning toward a flash flooding event for parts of the eastern half of Oklahoma. And then on Sunday, looks like the models do try to regenerate some more storms here across Kansas and northern Oklahoma, and then back into southeastern Oklahoma. These guys up here don't do too good just because they're probably running into stabilized air. And then in the afternoon, this whole thing will light up again with some surface features to work with. So that's the way that one looks. Let me see. The tech model, did the new one come in yet? It did. All right, so the tech model picked up on that stuff around Tulsa in Kansas today. There's some, however, in southeast Oklahoma. Had some helicity tracks all the way down here to North Texas. Let's see here. Those move off to the east, so that got a little aggressive. Let's see. It stops here at tonight, so it doesn't finish for tomorrow. So I'm going to have to go back to an older version of it, so we'll see what it did. All right. So it does that morning stuff there on Saturday, and there's some helicity tracks with it. All right. Then it just, instead, it fires stuff up before sunset here, kind of in the, so the other model kind of had it on top of the metro. This one kind of starts just on the west of the metro, but same idea, an instability axis that gets going. All right, and then that moves through central Oklahoma. So all those little red areas are helicity tracks, meaning there's a lot of rotation in a lot of these storms. And there's the actual dry line right here, / cold front on the move. It doesn't really have anything to work with at this point because the atmosphere is already worked over by the time it does come in. But we still have these big nasty lines of storms moving through the rest of the state overnight. So in this particular model, we can take a look at the helicity tracks. Here we go. All right, so these are helicity tracks. In other words, this is where the storms rotate. And the key point here is just to see how many are rotating. All right, so any one of these tracks, in theory, according to the model, can have large hail, damaging winds, and yes, probably a couple of tornadoes with them. So just you see how that's pretty much over central Oklahoma. Again, that jives with what you saw in the data from the Storm Prediction Center of the National Weather Service. So here's a close-up view. We'll look at the NAM first, and then we'll look at the HER. So we'll start you off the remainder of the day. It gets quiet. There's that stuff in the morning, around 10, 11 o'clock, noontime, 1 o'clock. If you do have anything to do outdoors here in central Oklahoma, you can see according to this model, it's not a washout, so you might be able to get your stuff done. People keep asking me, I got plans at 2, I got a party at 3, I got something going at 1. Unfortunately, you have to watch radar trends. Use my weather app, AT's Weather to Go. It's free. It's on Apple and Google Play. But if you believe this model per se, we dry things out for the afternoon. There's those storms that try to get going around 6. They vaporize. because they're in the wrong part of the environment. And then at 7 and 8 o'clock, we start to bubble things up here. And it just goes to town here over central Oklahoma. And now, the other issue I got to warn you about is, if you believe this, take it verbatim. This is I-35, this is 44. It stays mostly along and to the south and east of this boundary, which means most of the north and west side of the metro wouldn't get anything. So just keep that in mind. This can be wrong. It can be shifted, here, over here, just as much as it can be shifted here. It's not going to be that ideal, or that exact, I should say. All right, regardless, though, the signal is there, and that moves on off to the east for the rest of the night, very heavy rainfall. All right, let's see what the HER did, which is our other high-resolution model. And we'll see if it kind of has a similar look or if it just disagrees completely. All right, so there's Saturday morning. There's those storms that move through. Now this one keeps those afternoon storms going at 1 o'clock and 2 o'clock. So it actually has a pretty nasty-looking supercell with a little helicity track that does go through Oklahoma City, for example. Again, I got to caution you, anytime you see that, doesn't mean that's the exact placement, but it can mean there's be a storm somewhere in the area in the vicinity. Now, the difference between this model and the other one, this one does not have a light capping layer that has built in. The other one did. I will say the other one is typically more correct when you're forecasting for an inversion. So we'll see what happens for tomorrow, but if this one were to be pan out, it does indicate that there really wouldn't be much of a cap here at all, and that the potential would be for a tornado, and also hail up around 4 inches in diameter. So that would be some big hail with any of these thunderstorms. Now, if you had afternoon plans on Saturday, this model says, well, sorry to be you, right? So there's a little bit of a difference in the output. Let's go into the 4 or 5 o'clock hour. Now, as we head into that period, it continues to develop those storms in the same area here in central Oklahoma, and continues on into Texas and southern Oklahoma. Just kind of expands. See, a lot of these have little helicity tracks with them, and I'll show you a map of that here in a minute. Just kind of give you an idea of how much there is on the table. Let's see. If you notice, by the way, the dry line never fired anything. Let's go back. Here's 4, 5, and 6. So it says it's 2 capped out here. We're on the edge of the cap here. Therefore, let's just fire it off and stay firing it off, because we do have broad lift in the atmosphere as the storm system approaches. All right, so let's go through the 10, 11, midnight, 1 a.m., on and on and on. And there you go. So that can end up being some pretty decent flooding. I'll look at a rainfall output from this here in just a second. Meanwhile, helicity tracks. So there's that one that went through Oklahoma City, for example. And there's one up here in northern Oklahoma. There's a bunch here all over the place, southern and eastern Oklahoma, up around northeast Oklahoma. So keep that in mind. Any of these, yes, could be either tornadic, large hail, or damaging wind. That's the signal in the data. And then real quick, let's just see what this particular model does for the total rainfall, because it rained quite a bit and quite a long time over Oklahoma City area. Okay, so Oklahoma City, anywhere from 2, 3 to 4 inches of rain. Down the turnpike, same thing. Up the turnpike, about the same thing. Bartlesville looks like up to 7, 8 inches. Out here eastbound on I-40, there's pockets of 9. And I can tell you that even the global models for the last few days have indicated somewhere areas of Oklahoma may get up to 9 inches of rainfall. So this is not an unusual signal. This has been a pretty consistent signal. It's just they won't know the exact placement, but this gives you an idea. It still looks like it's kind of bounded in this sweet spot here across the state, and that seems to have been the consensus over the last few days. So flash flooding would be common in those areas. Okay, so let's just, I think that was really about it. Temperatures will be into the 70s and 80s for daytime highs, and the 60s and 50s for overnight lows. What I will talk about here briefly is tornadoes. So a lot of times, and most time I should say, 80% of all tornadoes, including here in Oklahoma, are the EF0, EF1. So they're weak tornadoes. Weak tornadoes are the best kind to have because they do the very minimum damage that you would find. So if you can make this out here in these pictures. So this is a home. They call it light damage, but you wouldn't even know you were hit by a tornado. All right, it's very, very weak. Here's an EF1. You're going to lose a few shingles, maybe a little small tree out front, part of your fence. Otherwise, not bad. EF2 on a home, well-built home, you can lose part of your roof for sure, but the integrity structure still stands. You can lose some big trees out front. On EF3, you can definitely lose the upstairs, if you have a 2-story home, and the roof along with it. But the structural integrity still stands, even though you do have some missing areas on the outside walls. So the inner part of the home is still usually safe and secure. So that's why we tell you to seek shelter in the middle of your dwelling. Now, if it's an EF4, or higher, well, now we're talking about areas that basically just take the whole slab clean, and or just leave very little behind. The good news is between the 4 and the 5 total, combined, 2% of all tornadoes. And that's mostly for this guy here. So F5s are so rare, I think they average one every 10 years or something. And to get stronger tornadoes, you have to have a couple things. They don't just easily form. First off, have to be a perfect environment, and usually kind of due to interaction with some kind of a surface boundary to work with, and or also what we call cell nudging, where you have other thunderstorms kind of bump into it. All right, and that basically adds the energy from that storm and the spin inside that storm, or the vorticity, the baroclinicity, and that gets ingested into the other storm, and then that can sometimes then ramp up and produce a tornado. So researchers are still figuring out all the little ways that you can actually get a tornado to form. It's really neat. I mean, the science has come a long way. We've learned a lot thanks to Doppler radar and also just some really good data accumulation that we have from different sources and projects. All right, so let me look real quick at the storm back up here to northern and northeast Oklahoma. So up here, last we looked at it, didn't really have a good low-level circulation. It looks like it still doesn't. Probability of a tornado is at 44%. Let me go back in time. Yeah, it has a very poor look to it, design structure. Now, I will tell you this. When I do track live tornado coverage and events like this, I will never tell you to disregard a tornado warning. I will tell you that it's not producing one, or that it can't, or that it won't for a while, and I'll tell you the reasons why. But in the case, you never want to just go, oh, okay, well, I'm not going to worry about it. You still, take shelter. You still, do what you got to do. But you can, rest easy at that time based off what the data shows, for example. So, let's say you're seeking shelter in your storm shelter, and then there's a tornado warning, sirens are going, you've got your anxiety up, you're all worried, and then you're watching me on your phone, your tablet, and I go, actually right now, the hook echo fell apart, that doesn't have any low-level rotation, it's all broad, so it's not producing a tornado right now, and it won't, because it's going to have to recycle as it's going toward your area, maybe over your area. That is what kind of you can just sit there and go, oh, whew. You can just breathe a sigh of relief. So all that kind of data and information is extra and additional that helps you to kind of analyze the situation better. So the more data you have, the better. The more you can think more logically, the more you can calm down, that kind of deal. So that particular storm, the tornado signature is gone on it. Actually, it wasn't even a tornado signature. The rotation had disappeared, and so they dropped the warning. It's just a severe thunderstorm at this point in time. But that storm had a tough time going. Just didn't really do much for today. Thank goodness. That's a good sign. But they did try. But I think that atmosphere was still just a little too worked over from the morning. That was the million-dollar question. Could the atmosphere recover after that big batch of storms last night? Oh, speaking of, I mentioned this on a post this morning. Let's see here. We did have some storms last night. So we only had, at least officially on the local storm reports, the one tornado in Bethel Acres. However, and that formed from a storm that kind of got its act together by the time it got to Norman, and then it got stronger for that little brief period of time. Outside of that, there was just a ton of wind reports. So there was a lot of damage just unrelated to tornadoes, just what we call straight line wind damage. So all these little dots here, you barely see them on the map, but this one, 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 this one. So basically just a scattering of severe wind reports. There's one there, even one down here toward Lawton, etc. So we did have some storms last night. If you lived on the northwest side of town in northern Oklahoma, I mentioned on the radar, on the model data, that the trend throughout the day had been to pretty much cut the metro in half and have the heavier storms from the metro to the south side and from the metro to the north side not have much at all. So if you're in Edmond and Piedmont and you're disappointed, don't be, because you don't want what came last night. It was a rough ride for some folks. So anytime you do not get rain, when it's going to come with hail, wind, and potential tornado, just be glad you didn't get it. So the models did really good last night at picking up on that little deal. So that's the latest that we've had to work with. That's been all the trends. Like I said, if you haven't had time to kind of get acclimated or caught up, that's everything up to now. This evening around 9 o'clock, the new data will start to trickle in. And so I'll go live around 9:30 and we'll look at it together, see if anything has changed. But for right now, if you're late, you're just now tuning in, you kind of missed the whole thing. The bottom line is we had more storms coming. Yes, there'll be some hail, wind, and probably a few tornadoes. There could be some strong tornadoes, and they'll be coming. The main wave will be Saturday evening and overnight, again, unfortunately, just because of the timing of how things work out. And if you believe the model data, we'll have a lot less of a cap to work with over central Oklahoma for that event. So which means a higher probability of tornadoes. The cloud bases, what we call LCLs, will be pretty much down at the floor level. You can probably reach up and touch the sky, is what that means. So if you ever hear low LCLs, that's called the condensation level, lifting condensation level, which means basically where the cloud starts to form, the base of it. And sometimes in events like that at nighttime where there's so much moisture around, it looks like it's almost touching the roof of your house, like the base of the cloud. So the lower that cloud base is to the ground, the easier it is for tornadogenesis, one of the many components you have. Just another signal in the atmosphere that things are ripe for that to occur. As we said, always, middle part of any structure is where you need to be, away from all outside walls and windows. And you can use a bathtub, you can use closet, it can be a stairwell, whatever you have that's in the centermost part of your home. For kids, they can put on their sporting helmets and pads, you can put blankets, you can put a mattress, whatever you want to do. If you're underneath the path, remember my weather app, AT's Weather to Go, it will send you a twisting storm alert. So a twisting storm alert means that not only is the storm rotating, but it's rotating enough to where that the algorithm is guaranteeing a tornado if the BTI number is a certain value. So the BTI number is a scale of 1 to 10. If it's a 7, 8, 9, or 10, it's a tornado. So hit the deck, don't even think about it. If it's a 4, 5, or 6, it means it's rotating really hard and it's on the verge of producing a tornado. You might want to go ahead and get the shelter just to play it safe. If it's a very low number, it just means that the storm itself is rotating, it has some ingredients, and it's not yet at that period to where it would produce a tornado. It might later, but not at the time where it sent you the first initial warning. So it's just kind of a heads up that you've got a storm coming. And this is based off your GPS and or your physical address that you put in the phone. So in other words, it's not going to bother you if there's a storm, say for example in Edmond producing a tornado and you live in Norman. You're not going to get the tornado warning for that because you don't live there. Therefore, it's not going to bother you. So we keep what we call the POD high and the FAR low. POD is probability of detection. FAR is your false alarm ratio. So you want your POD high, you want to detect them all, but you don't want to overwarn and have false alarms. So you keep that low. So this is a very specific track that it provides for you so that you know if you really do need to seek shelter. So check it out. It's free, Apple, Google Play. I've already had some case studies here this spring where people used it and they were in the path in the Barnsdale tornado, and one lady grabbed her baby and went to her neighbor's house just in time because they had a lot of extra time because my app gave them more time before the official tornado warning came out. So that was good for them, right? So you want to take advantage of that. Let's see. Let me see if you guys had a couple of questions. Close that down. Let's see. Lexi must have just tuned in. You kill me, Lexi. Yeah, so somebody had a tornado question there. I kind of just went over it a minute ago with the strengths and the wind speeds on that graphic. So you must have missed all that. I did it probably right before you asked that question. So you can always go back and hit the replay for all that. You can always, in the replays, you can just drag the cursor and see what you want to see that's interesting to you, right? Because I do a lot of the explanation as to how, when, why, and what, and I tell you my thoughts along the way so you can learn to be an armchair quarterback of meteorology with me, and that way you have all the knowledge in your head. It's like, oh, okay, I know what's going on, I understand it, and I know the hows, the whys, and whats, versus just telling you the whole state, oh my gosh, large tornadoes everywhere. That doesn't do you any good, right? So I tell you everything else behind the scenes so that you understand what's happening and really where the areas are to focus on. And as far as tornadoes are concerned, for Saturday, if the cap were to break in that little small area, northwest Oklahoma near Woodward, that'd be one favored area. It's a lower probabilities because of the data. The other area is going to be really pretty much right along central Oklahoma up to, let's just say, I-35 corridor, and that means east and west, okay? So from the top of the state through Oklahoma City and then back down 44 to Lawton. So that's kind of your little line in the sand, give or take along that line at the start of the event, which, again, there's two modes here the models like. They like the evening, so say 7, 8 o'clock where all that blows up, and that slowly moves east. So from there to Tulsa, etc., would be your ideal area for tornadoes, along with all the other stuff. Now, that's one slew of models, and we need to see the other ones come in to see which way to lean toward, because the other seems to think that no, we'll start the storms, from the morning, which they'll be marginally severe. I can't rule out, hail or a brief tornado somewhere, but the atmosphere isn't quite ready for that yet. So I think it'd be more of a freak thing at this point in the data, unless something changes in tonight's runs. But regardless of that first wave that moves through, there is one thought that it never really stops, and it just keeps forming from that point south and west. Now, for that to occur, we have to eliminate the cap completely earlier rather than later. So that's the difference maker. So if that cap were to be completely eliminated, then we would get some storms that kind of keep trailing one after another along the central Oklahoma corridor. All right, but if the cap is just a little stronger, which is what the other model suggests, then we have to wait for the evening for it to completely erode, and then we get more of that action. Which model am I leaning toward? Believe it or not, the one that says we're still a little capped is typically the more accurate one with that. But we'll see what happens. I'll look at the new data tonight at 9:30, and then we'll make any minor adjustments that are required. But the point is, really all we're doing is splitting hairs, trying to find you some dry weather to get your afternoon stuff done. So there's a lot of afternoon festivities. So you can check it at 9:30, you can check it in the morning. Otherwise, you can use my radar on my app to kind of plan around it. Grounds will be wet, so if you have anything to do outdoors, you might have some puddles, some mud to deal with. But then flash flooding may be a problem. And people don't really pay much attention to flash flooding either usually. Believe it or not, it's the number one killer when it comes to weather. It's a silent killer because nobody pays much attention to it until you're in it. It doesn't take much to, as you as a person, knock you down. If you have, rapidly moving water, like a stream, for example, in a creek or street or stream nearby, whatever it may be, a city that city street doesn't drain very well. About 6 inches of water, believe it or not, if it's moving really quick, can knock you off your feet. If it's a car, we're talking about a foot of water or so, depending on how big the car is, how heavy, but it will also float. So bridges a lot of times get washed out. You won't be able to tell because it'll be covered in water. You think you can drive over it, and all of a sudden you find out you're not, and now you're in the creek, in the car upside down. So all that kind of stuff does happen, and especially at nighttime, that makes it even more dangerous. So that's always the bad news in those situations, unfortunately. So it's never good to have tornadoes on one hand and flooding on the other. If you're trying to seek shelter from a tornado, for example, that's kind of a bad combination, right? Because, man, what do you do? Especially if it's at night. Let's say you got a tornado, barreling down on you, and you don't know what to do, you don't know where to go, so you just want to hunker down, you want to find someplace safe. And the old adage that we tell people is you go into a ditch. Well, that's great unless you have flash flooding. Then you can't go into a ditch because that's not going to do you any good. So you had to find some other place. And that's difficult. And that's a lot of thought process you have to have on a very short order of time. But you typically want to find a building somewhere, very strong, sturdy building. And in a worst case scenario, if the roads aren't bad, the traffic isn't bad, storm chasers, they will drive south to southeast to get away from a tornadic thunderstorm, assuming that tornado storm is moving to the northeast or east. So they kind of just basically, if they get in a tough spot, they just jot this direction just to get away from it. And then they can always reposition later. I know there was an issue here not long ago where somebody, I'm not going to get into it, but somebody told the whole city to head south. That was a bad idea. That was a traffic gridlock as a tornado was barreling down. And luckily, that thing lifted before it came in, because that would have been the worst combination I think I could have ever known. That, even though that instruction is true, it's not true for tens of thousands of people at once. It's true for you and your chase buddy next to you, or you're out there driving around for lunch. It's true for you, but it's not true for everyone all at once. That's not the way it's going to work. So that's kind of how that happens. If you do hear tales of that, that's kind of the backstory of where that went. So yeah, if you find yourself in a bad situation, if it were me, for example, let's say I've got my weather app and it says, hey, twisting storm alert, BTI of 8, and I'm looking at the radar and it's coming right for me, has a little arrow on it. I'm like, well, I'm not going to sit here and just get hit by it if I have a chance to move, right? So I will, if I'm in a car, of course, I'm traveling around, then I'll just go south or southeast and get out away from it very quickly, and then let it go by me, and then I'll go back to do whatever I was doing. When you're in your home, however, unless it's a mobile home, right, or unless you know that you're in a structure that is not well built, it's on cinder blocks, or it's not up to code, I don't know how old it is, whatever it may be, if you know that the structural integrity of that is not where it needs to be, and you feel a little vulnerable, you need to have either a storm shelter in that facility, or you need to leave and just make plans to go somewhere else that day, that night, for those few hours until the storm is over. So that's what you have to do if you're in that situation. Otherwise, every home here that's built to code on a slab with 12-foot, anchor bolts in, that's, built correctly, you'll be fine again all the way from an EF0 to an EF3 tornado, which will cover, 98% of all tornadoes. So there you go. Okay, let me think. I can show you. Yes, Nicole, you do go south because typically, not all the time, there's always a freak occurrence, but 95, 99 times, those storms do move in a northeastward fashion, some vector of northeast. Sometimes they move north, sometimes they can move due east, but it's usually on an average a northeastward vector. Now, we'll call it a right mover, or they turn to the right. That usually means they move east. Sometimes they can move a little bit south of east, but it's very rare for a storm just to go south. There's other things at play that would cause that. It would only be very, very brief. And that's kind of like up to the El Reno storm. But that was a rarity. Outside of that, they typically move in that direction. So I know because I was chasing that day in El Reno, and we went south to get out of it because there was too many people on the roads. It was road traffic jam. We couldn't go east like we wanted to anymore. So we said, man, I don't want to get caught in that traffic. This thing's starting to ramp up and it's getting bigger and it's going to come east anyway. So we just went south thinking, all right, we'll go south, then we'll go east, and then we'll go back north, and we'll kind of reposition. But what we didn't know at the time was that there was some other things going on within the storm, and the thing decided to go due south and then do like a little hook, like a fisherman's hook, just a little Fujiwawa, and just go whoop, just like that. And it nearly got us. So 8 seconds later, it wouldn't be here. Let's put it that way. So that's why I do this now at home versus chasing in the field. It just became too dangerous, and the fun was gone when there were too many people on the roads. It eliminates your escape route, so to speak. I will show you one more thing, and then I'm going to let you go, because I did this last night, and I think a lot of you enjoyed it. And if you didn't get to see it, I want to give you a perspective. Remember, the more data you have, the better. Kathy, you have to have at least, you have to have an interior spot of your home, unless you live in a box where the outline has absolutely no inner walls at all. You have to have something in there. So you might have a big open floor plan, for example, for the kitchen into the living room is probably what you're thinking. But you're going to have a closet there, either in the entryway, or you're going to have some little hallway there. So there's going to be something there. Or maybe the hallway itself is an area, but you will have to have something there. Nobody just has an open floor plan where it's just 4 walls and that's it, and you just put a cot in the middle. Well, unless you're, student at college, an apartment. I think I've been there, done that, but most homes aren't made that way. Okay, so let's go. Yeah, let's do this. Let me move this over here. And, okay. So I showed this the other day. I want to give you a perspective on tornadoes. All right, so let's remove those. Okay, so when we talk about tornadoes, especially if you're not from around here, and you're going, oh, all I hear is you guys have tornadoes all spring long, and that's not exactly true. We do have 3 months where we do deal with the majority of those, but we don't have that many, and they're like needles in a haystack. All right, so this is all of Oklahoma. Basically, you need to learn where you live. In other words, learn what county you're in and learn what nearest town you're under or city. But let's just take a look here. So as we zoom into Oklahoma, we have on this map 3 tornadoes already. Do you see them? Nope. All right. Well, zoom in a little more. Do you see them yet? Nope. A little closer. Nope. Remember, these are drawn to scale, actual size tornadoes. All right. What are you starting to see here? You see these 3 little blobs showing up? All right. So I have 3 tornadoes plotted on the map. I'm going to show you the most common one first. That's this guy. All right. Let me get that off there. There we go. Okay, so this is a 5,000 foot example of a column of rotating air. And this is our EF0 to EF1 tornado, which can be as, believe it or not, it can be as small as 50 yards. It can be 100 yards. It can be maybe 200 yards. I took an average on the high end. I just said 150 yards to make it easy. They have winds less than 110 miles per hour, and they are 80% of all tornadoes. So this is what we have mostly across the whole United States, including Oklahoma. All right, now look at the size that it's on the map. So these grids out here, this land that you see here is 1 mile each. So this is a 1 mile grid. Now look how tiny that thing is compared to 1 mile. So you know a football field? You know, you go to a football stadium. This is basically the size of a football stadium. Okay, so that's good. Now remember, this is what would be out, and a lot of times these things happen in these areas, farmland. There's nothing there. I mean, there's literally nothing. Wheat, maybe a few bushes, a tree, a cow, and that's about it. So that's good. A lot of those do happen in those areas because we have a lot of land in Oklahoma that is not populated. Okay, so now let's go to the second group here. So the second group, this column right here, and that is the EF2 to EF3. So these are winds that are up to 165 miles per hour. They compass about 18% of tornadoes. So there you go. You got our 98% of all tornadoes in these first 2 examples. They can be up, the width can be up around 300 yards. Not always, but sometimes. And if you look here, once again on a square mile, still relatively small. All right, now this is the one that gets all the attention, all the action, all the news reports, all the clicks, all the talk is this guy. Why? Because it's the biggest. It's this guy right here. And he is in the category of the EF4 and 5. So in this example here, I drew it as a mile wide. So sometimes you'll hear a mile wide tornado, and then there'll be an EF4. Sometimes they can be larger than that. They can be up to 2 miles. Doesn't mean you have these type of winds, 200 plus mile per hour winds, all in the entire 1 or 2 mile radius. A lot of that times that's within the core, the central structure. It just means that the wind field itself expands outward. That can be measured because on the outer ends they'll be a lot lighter. The winds will be a lot weaker. But as far as the width of the tornado goes, yes, this will be the largest and also typically the strongest. And the 200 mile per hour winds is basically a Fujita rating, which means this is the level at which pretty much most structures are destroyed. So anything over 200 is like, you know, the insult to injury kind of a deal. It's not going to do anything different from that. But Doppler radar has measured wind speeds up to 300 miles per hour. And they argue in the science world as to whether or not that was ground-based or a few feet off the ground, what happens at the friction layer, was the radar calibrated. So there's all kinds of arguments as to where the final number is, but it doesn't matter. Point is, on the engineering side, they figured 200 was all that was needed. So yes, those Doppler radar, or yes, those tornadoes can get higher than 200 if they're on the EF5. But remember, that's like an average of once every 10 years. And both of them combined, we're talking 2% of all tornadoes. So there is how things look comparatively speaking. So keep in mind, we will deal mostly with these. On our Saturday night, we'll probably have, or maybe even Saturday afternoon, if things go well, you know, we would have maybe a couple of these to deal with. So we're still dealing with probably this category. For this to happen, just so you know, you have to have a lot of things perfect lined up. This is not easy to do. You have to have sometimes a surface boundary. So you'd have to have a storm, like a supercell storm that looks like this with a hook echo. And you have to have a surface boundary ingested into the storm. Now there's arguments in the research world as to whether or not this will provide more hail and less of a tornado risk. But if you look at the big picture of these guys, a lot of times there is some type of boundary that comes in. It's a baroclinic vorticity that's added to the storm. And that can be either from some type of outflow boundary from other storms, or it can be a storm itself as an east-west elongation that gets into the storm. There's also storms that could like be out here, for example, and maybe they merge into the storm. They come in the backside, the RFD. So these are all called nudging. So all this stuff has to happen, and it is very difficult to get everything in the right place, right time, to get a storm of this magnitude. It can happen, but it is very rare. So the point being is, when you get under a warning, you're typically not either going to know what's coming, so just you treat all tornadoes seriously and you seek shelter until the thing is over. If you're able to watch, like me online, and I can tell you what the wind speeds are in that particular tornado, I can say, hey, Doppler radar is measuring, 100 mile per hour winds, and you can go, oh, that's a baby tornado. Okay, I'm good with that, right? But either way, you're going to be seeking shelter anyhow. But it's just we have a lot more stuff we can do nowadays than we could in the past. Okay, so that was it. There's just more extra stuff since we were live and I had a lot of extra time here, just to kind of give you more ins and outs behind the scenes of what goes on in these type of situations. That's what I'm saying. When you're told tornadoes for 7 days in a row, and they don't happen, half of you get angry. The other half, you're like, well, I'm good. I'm glad it didn't happen. I'm glad I was prepared. My question to you is, how do you prepare 7 days for a tornado? Because in my world, you know how long I prepare for a tornado? About 30 seconds. Because that's what it take me to get from wherever I am in my home to my shelter, which is basically for you too. Anything beyond that, I can't plan for something that doesn't exist, and/or I don't know where it's going to be. That's not a logical step for me. If I had the ability to tell you, okay, Oklahoma City on next Saturday at 7 p.m. we're gonna have a tornado coming through Penn Memorial. You'd be like, whoa, that's 7 days prepare, and that's an accurate, real deal. It's gonna happen. I said, yep. Okay, what could you do? You could do a lot of stuff. You could sell your home. You could pack up and leave town, but we can't do that. So without that type of structure associated with it, well, Saturday we're gonna have a tornado, there's no meaning. It's a worthless thing to say. Besides that, you can't even guarantee it's actually going to happen because you don't even know all the ingredients in the atmosphere required to make the tornado. And I'm going to tell you this, you can have every ingredient in the world to bake the perfect ideal cake, and you can still screw it up. Same thing in the atmosphere. We can have all these ingredients in the atmosphere. At the end of the day, if that particular storm that is trying to become tornadic does not have some favorable component at that moment, this doesn't happen. It's pointless. It didn't matter. So again, it's not always a guarantee. And so that's the frustrating yet good thing, right? Frustrating because on the prediction side, you want to be able to get everything right and be accurate. But on the other side, it just means we still have a lot more to learn about the whole phenomenon. So it just means the science still has more to settle, which is good. So it's a good thing to be in if you're interested in that stuff. It's really neat. So anyway, so that's everything for me. I'm going to get out of here. I got to go to the gym, get a workout in for Friday, and then I'll be back here at 9:30, and we'll look at some new data, and then we'll go from there. Thanks, guys, for tuning in, for liking and sharing the video, telling your friends and family about AT's Weather. Get my weather app, AT's Weather to Go. It's free, Apple, Google Play, and we'll talk again with you very soon. All right, take care. Bye.